All right, so we've worked with exponents since the beginning of the year with order of operations, and we're going to get to a few properties that deal with them. The first two properties we talked about was anything to the 0 power is 1, and a negative exponent will put something in the denominator, or if it starts out in the denominator, we'll put it in the numerator. It'll move it. So now we're going to start getting to multiplication properties. They showed this in what's called expanded form. So expanded form is just when they write 8 to the 4th, 8 times 8 times 8 times 8. Or when they write 8 squared, 8 times 8. That is called expanded form. And so if I were to multiply 8 to the 4th times 8 squared, you'll see that you get 8 to the 6th power. 1, 2, 3, 4, 5, 6. Same thing happens when I have 8 cubed and 8 cubed. If I multiply these two, I get 8 to the 6th. It's 3 and 3. And this is where our property comes from that we're going to deal with today. Multiplying powers with the same bases. So if you have the same base and you are multiplying them, you are going to be adding their exponents. So this is what it says. For every non-zero number, a, and the integers m and m. So a to the m and a to the n, and you are multiplying these. You would say a to the m plus n. You add their exponents. They give the examples. 3 to the 5th times 3 to the 4th is 3 to the 5 plus 4, or 3 to the 9th. It works with variables as well, as long as the bases are the same. H squared times h to the 9th is h to the 11th. You just add their exponents. So let's look at the first example. Rewrite each expression using only the base once. So we're going to just rewrite them. We want to leave it in base 11, but we are going to say 4 plus 3 there. So that would be 11 to the 7th power. Here, using the base 2, we are going to add the 5 plus the 2 plus the negative 1, and we will get 2 to the 6th. And then 5, negative 2, plus 2 is 5 to the 0. We have already learned what this is. So you don't want to leave anything to the 0 power. You want to simplify that, and your answer here would just be 1. All right? Add your exponents. So try check understanding number 1 there. All right, let's go over these. For the first one, 5 cubed times 5 to the 6th, you should have gotten 5 to the 9th. 2 to the 4th times 2 to the negative 3rd, 2 to the 1st power. And then 7 to the negative 3rd times 7 squared times 7 to the 6th, you should have gotten 7 to the 5th. All right, the same thing holds true when you have variables involved. So for the first one here, we just have base x to the 1st power. So if you do not see a power listed, that is to the 1st power. X squared, x to the 4th. You are going to add your 1, your 2, and your 4 there, and then you will get x to the 7th. So then what happens when you have coefficients? So here I do have the same bases. I have n and n, but I have a coefficient here. And so for coefficients, you just multiply those. So you can reorder this because it's all multiplication. And so here you just multiply your coefficients, a 6. And then because these are like bases, you are going to add your exponents, 5 plus negative 2. So you would get n cubed. So when you do have a number in front, just multiply those numbers. That will be your new coefficient. And then you will add your exponents for your like bases, and that will become your new exponent. Go ahead and do check understanding number 2. Good work. For the first one, a to the 1st times a to the 5th, you should have gotten a to the 6th. N squared times n cubed times 7n gives you 7n to the 6th. 6y squared times 3y cubed times 2y to the negative 4. 36y, 36y. All right, so look at example 3. You have to keep in mind when you do this, you only simplify if you can. So if you have like bases, then you're going to simplify the variables. Any coefficients will simplify. So for this first one, we only have coefficients of 1, but D is not going to be a like base to the other two. So the only like bases we have here are c to the fourth and c to the second. So we can combine those. We would have c to the sixth times d to the negative third. But from our prior section, we would not want to leave d to the negative third. You don't want to have any negative exponents in your answer. And so we know that that is going to move it to the denominator position, which is going to give us c to the sixth over d to the positive third. All right, so we only simplify the ones that can. And then if we have any zeros or negatives, we're going to simplify those as well. Look at the next one. So for this one, we have x's and x's here, but we can actually simplify all of our coefficients. The 5, the 2, and the 3 can be simplified. So we're going to say 5 times 2 times 3, and then we're going to simplify our x's. And then our y really can't simplify with anything because it does not have a like base. And so we would say 5 times 2 times 3, that would give us 30 here. And then we would add for our exponents for our x's, the 1 and the 8 would give us x to the 9th. And then because our y doesn't simplify with anything, it would stay exactly the same. And so you're going to look at what you can simplify and what you can't here, and do all that you can to make it as simple as possible. So go ahead and simplify those three, A, B, and C. All right, let's check your work. For the first one, you can combine the A's. You cannot combine the B. So you're going to end up with A to the 6th, B. A to the 6th, B. For the second one, you're going to multiply your 2, your 7, and your 2, and then you can combine your Y's. So you'll end up with 28. X squared didn't change, but then you have y to the 7th. Y to the 7th. Question. 7 doesn't combine with anything, so your coefficient's going to stay as 7, but you can combine your m's, and you can move your n. So you end up with 7m cubed over n squared. 7m cubed on top, n squared on bottom. Multiplying numbers. So we did scientific notation. But we had one number on the outside, right? We did not have two sets of scientific notation. And so keep in mind, this is all multiplication. This is not distribution. This is not foiling, all right? So we've done those, but we are not doing distribution. We are not doing foiling. This is simply 4 numbers being multiplied together. Think of it as like 2 times 3 times 4 times 5. It's literally 4 numbers being multiplied together. But because it's in scientific notation, what you're going to do is you're going to multiply your whole number pieces, like your numbers that are on the front part of your scientific notation. So here we would multiply the 7 and the 4, and that would give us 28. And then we are going to multiply the 10 to the powers. So we have 10 squared times 10 to the 5th. These are like bases, And so because these are like bases, we can just add these exponents and get 10 to the 7th. Now, when you do this, you want your final answer in scientific notation. Is this in scientific notation? This one would not be scientific notation because the 28 is too big. And so to write that in scientific notation, I need my decimal point right here, which means I moved it over 1. It was bigger than 10 to start out with, so I should add 1 here. So my final answer would be 2.8 times 10 to the 8th. 2.8 times 10 to the 8th, all right? So you're just multiplying the pieces in front, and then you're doing your like bases shortcut for your 10, and then you're making sure your final answer is in scientific notation. So try those 3. And so when you do this particular one, you would have gotten 4.5 times 10 squared, 4.5 times 10 to the 2nd power. And then for the last one, multiply your 9 and 7, and then add your -6 and -9. And then that would not be in scientific notation, so you need to then move your decimal place over and add 1. You would have had it -15, but then you add 1 to the -15 to get -14 there. -14. Questions on those 3? More multiplication properties. So the first one we looked at was when you multiply like bases, then you add your exponents. Here in the middle of the page, they give you some examples. They have something like 3 to the 6th squared. When you have something squared, you just multiply it by itself however many times. We just learned that when you multiply like bases, you add their exponents. So you get something like this, right? If you look at the next one they gave us 5 to the 4th cubed, which written out would look like this. And we learned we add those. So 4 plus 4 plus 4, 5 to the 12th. What you'll see happening is the next rule, that when you take a power to a power, you multiply those exponents. So I have 3 to the 6th, the whole thing raised to the 2nd. 6 times 2 is 12. I have 5 to the 4th raised to the 3rd, a power to a power. 4 times 3 is 12. And so that's the rule that they've given us down here for every non-zero number a and integers m and n. A to the m raised to the nth. You multiply your exponents. The examples they give us, 5 to the 4th squared. 5 to the 4 times 2 is 5 to the 8th. N to the 2nd to the 5th power is n to the 2 times 5, which is n to the 10th. N to the 10th. All right, so if you look at the first example here, they want us to simplify x cubed to the 6th. And so since this is a power to a power, we're going to say 3 times 6, or x to the 18th. If you had any other things you need to simplify, you would do it there. So go ahead and try check understanding number 1. For the first one, you have a to the 4th raised to the 7th. So you would say a to the 4 times 7, which is a to the 28th. The next one looks similar, but it's a little different. You have a negative in there. So we have a to the negative 4 times 7, a to the negative 28th. You do not want to leave a negative in your exponent, so you're going to put that in the denominator position, 1 over a to the 28th. Next example. So for this one, we have like bases and we have a power to a power. And you're going to think of almost like an order of operations here. You want to do your power to the power first, and then you want to do your multiplication of your like bases. So you want to then take this right here and simplify it first. So we have c to the 5th times, and we're going to say c, 3 times negative 2 is negative 6. And then we're going to use like bases being multiplied. So this would be c to the 5 plus negative 6. And so that would give us c to the negative 1. And then our rule about negative exponents would say that is 1 over c. 1 over c. And so you're just doing it a step at a time to simplify it. Step at a time to simplify it. So try your check understanding number 2 at the bottom there. Check understanding number 2. The first one, you want to simplify the 4 and the 3 first, the 12. And then when you want to add your 12 and your 5 and get into the 17th. Into the 17th. For this one, this next one, you want to simplify the 7 to the negative 2, which would give you a negative 14. And then you want to add the 2 and the negative 14, which gives you negative 12. So you should have had 1 over t to the positive 12. 1 over t to the positive 12. And then for the last one, you want to simplify them individually. So this would be a to the 8th, a to the 10th, and then you're going to add those because you're multiplying like bases to get a to the 18th. A to the 18th. Questions on that one? All right. Let's look at ones that have a group taken to a power. So for this property, we have the example here is 3 to the x to the 4th. 3 to the x to the 4th. And if I were to write that out, I would have 3 to the x times 3 to the x times 3 to the x. And you'll notice that I have 3, 3, and 3. So you end up with one more. There we go. 3 to the 4th and x to the 4th. And so that's what this particular property tells us for every non-zero number a and b. So this is when we have more than one thing inside this parentheses taken to a power. We're going to take everything in the parentheses to that power. And so that's what happened here when we did this. We had 4 3's, which gave us the 81, and then we had x to the 4th. So we had 81 x to the 4th. Let's look at example 3. So we have 2x squared raised to the fourth power. So we're going to take the 2 and we're going to take that to the fourth power. And then we are going to take the x squared and take that to the fourth power. If we have a number, we want to simplify it. 2 to the fourth power is 16. And then here we have a power to a power. So we're going to use our rule there, and we're going to have x to the 8th. And so when you have a group taken to a power, everything in the group should be raised to that power. So go ahead and try A, B, and C there. All right, let's look at these together. The first one, you should have taken 2 to the fourth power, and then you should have taken z to the fourth power. So for this one, you should have gotten 16 z to the fourth power. For the next one, you have 4 to the negative 2, g to the 5th to the negative 2. And this would actually put all of it in the denominator. So you would have had 1 over 16g to the 10th. 1 over 16g to the 10th. And for the last one, you have 3 to the fourth power and t to the 0 to the fourth power. 3 to the fourth power is going to give you 81 here. And then when you do 0 times 4, you're going to get t to the 0 power. But anything to the 0 power is just 1. So you end up with 81 times 1, which is just 81. Just 81. So questions on let's look at B together. All right, so for this one, we have 4g to the 5th, and all of that is taken to the negative 2 power. So I'm going to say 4 to the negative 2, and then I have g to the 5th to the negative 2. All right, remember if it's to the negative power, it's going to go in the denominator. So 1 over 4 squared. This becomes g to the negative 10, so that's 1 over g to the 10th. And then I want to simplify my numbers. So I end up with 1 over 16 times 1 over g to the 10th, which gives me the 1 over 16 g to the 10th. Make sense? For this one, we have 2 groups taken to a power. So you need to take those groups individually and then simplify anything that you can. So then if you have like bases or whatever, then you're going to simplify them. And so we're going to do it individually with this first one. We have x to the negative 2 raised to the 2. So we're going to multiply those. Negative 2 times 2 is negative 4. 3 to the 4th power. So we're going to do each one of these to the 4th power. And we have this last one, y squared to the 4th power. And so we want to simplify these. 3 to the 4th power is going to give us 81. I can simplify my x's. These are like bases, so I'm going to add my exponents. So I have x to the negative 4 plus 4, which gives me x to the 0. And then this is a power to a power, so I'm going to multiply those, y to the 8th. I do not want to leave anything to the 0 power because that is just 1. So it's 81 times 1 times y to the 8th. So you end up with just 81 y to the 8th there. All right. So you want to simplify as much as you can individually, and then whatever you can combine, you want to combine. All right. So go ahead and try these. I will say for these last two, instead of, these are going to be very large numbers, like 3 and 4 digits. So you can just leave them to the power. So like 2 to the 5th, 3 to the 3rd, and then I'll give you the answer when you multiply it out. And so for this one, you're going to multiply the 2 and 3 and get 6. 3 needs to be taken to the 4th power, and the c to the 5th needs to be taken to the 4th power, which gives you c to the 20th. 3 to the 4th is 81, and then you would add these two, 6 plus 20, which would give you 81c to the 26th. For the next one, 2 needs to be taken to the 5th power. A cubed needs to be taken to the 5th power, so 3 and 5 give you a to the 15th. 3 needs to be cubed. The a needs to be cubed, and then you have b squared that is cubed, so you multiply these and get b to the 6th. You would multiply your 2 to the 5th and 3 cubed. That's where they get the 864, by the way. You could have left it like this for me for this exercise. Combine your a's, 15 and 3, 18, and the b can't combine, so it's b to the 6th. For the last one, 6 needs to be cubed, the m needs to be cubed, and the n. The 5 needs to be squared, and then you have the -3 squared, so this is to the -6th. You would multiply your 6's and 5's here. Combine your m's. +3 and -6 is -3. And then the n can't combine, so it's just +3. This -3 would put that in the denominator. Look at the last example. And then I don't like the one they gave you, so I pulled one from the book. All objects, even resting ones, contain energy. A raisin has a mass of 10 to the -3 kilograms. The expression 10 to the -3 times 3 times 10 to the 8th to the 2nd power describes the amount of resting energy in joules the raisin contains. Simplify the expression. And so you'll notice on this, they have just 2 things taken to a power. And so we just do everything in there taken to a power. So we are going to leave the 10 to the -3 alone for right now. And we are going to deal with this part. So we're going to take the 3 squared, and then we have 10 to the 8th squared. So we need to take that 8 times 2 and make that the 16. And then once we have that, we need to combine my 10s. These are like bases. So we have 3 squared times 10, and we're going to add these two. -3 and +16 give me 13. And then I can go ahead and simplify that 3 squared, 9 times 10 to the 13. Now, if my answer were not in scientific notation, I would fix that here. But if you have a scientific notation and the whole thing is taken to a power, you just take each piece within it to that power. So go ahead and try number 28. It's actually on page 414. Number 28 on page 414, a power to a power. All right, let's look at this one. You need to take everything inside to that power. So we have 6 squared. That gives us 36. Times 10 to the 12th squared. We multiply those. 10 to the 24th. Is this scientific notation? No, this is too big. So I need to move that decimal place over and add 1. So your answer here would be 3.6 times 10 to the 25th. 3.6 times 10 to the 25th.